Oh, hi. Okay, the camera's still on. Well, that's okay. Here we go. 3.2.6, step 2. So we determined the beam loading in step 1, and now we're going to determine the reaction forces. The reaction forces, I'm just going to kind of sort of quickly sketch like
Very good. All right, so listen, I'll turn
a
it over to Steve.
free
Let
body
him say hello.
diagram sort of thing.
And I'm just going to
And
run into
as
the
I've
kitchen
been
for a
mentioning
moment,
all
and I'll be
along,
back.
we can pretty
AA1,
much
you
assume
get it?
that
FYA.
the horizontal forces are 0 because we're not really concerned about those for the beam design. You would have to consider lateral forces in designing a building, but that's beyond the scope of this activity. So all we're concerned about here are the two reaction forces, RAY and RBY. And at that point, at either end, well, in this case, it's a symmetrical loading, so they're going to be the same, but that's where your maximum shear exists as well. If you remember your shear diagram, it looks like this for this type of loading diagram, and so your maximum is right there, right at the end. So let me erase that so that we can then do the math. So here's your formula. Reaction force RA, and you could put a little y back there and down there if you want, because it is the vertical component. RAY equals omega, or W, that's the loading, times L, which is the length of the beam, over 2. So you just got to make sure your units are the same. So since we have pounds per linear feet times feet, is going to give us 1,000 times 18 over 2. And this is pounds per feet times feet. The feet cancel, and you get 18,000 divided by 2 gives you 9,000. 9,000 pounds, or 9 kips. So that's the reaction force at RA and at RB. They're equal because it's symmetrical. That is also your maximum shear for the shear calculations that we're going to do later on. So now we're going to do maximum moment. Here's the formula for maximum moment. You could, of course, draw your shear and moment diagrams and use the area under the shear curve to do the maximum moment. But I think most of you at this point would rather just plug and play in the formula. So maximum moment is W, hello, omega L squared over 8. Omega L squared over 8. Let me touch that up a little bit. So that's going to be 1,000 times 18 times 18 over 8. And of course, well, divide that by 2, you get 9. Divide that by 2, you get 9. Divide that by 4, you get 2. So it's 9 times 9, 81 times 1,000 divided by 2 is 40,500. And remember the units. Now, notice the units here. If I were going to take the time, and you should always do this, pounds per lineal feet times feet squared are going to give you foot pounds or pound feet. So those are your units. There's your maximum moment. So that's it for steps 2 and 3. And we're going to skip not skip it, but we're going to use the maximum moment and shear to go do our initial selection of the beam design, the beam selection, and then we're going to come back and do the deflection, because that's a little bit more of a gnarly equation.